Welcome to the third lecture on circles. In the last lecture, we concluded with the method of deciding whether a point is inside a circle or not. In this lecture, we will be moving ahead and we will see how we can find out if a given line and a given circle intersect, and whether they intersect at 2 points or 1 point or they do not intersect. Similarly, we will see how to find out the intercept of a circle on both the axes, followed by some problems. And if we have time in this lecture, then we will also cover the method of finding the equation of the tangent and normal to a circle at a given point. So, just a little bit of recap on what we concluded with in the last lecture. So, suppose if we have a circle C whose equation is x square plus y square plus 2gx plus 2fy plus c equals 0. So, we know that this defines a circle, let us say over here, with center at minus g minus f and a radius r equal to square root of g square plus f square minus c. Now, suppose we are given a point P whose coordinates are a and b. The question now is, how do we check whether this point lies in this inside this circle, or does it lie outside, or does it lie exactly on the circumference of this circle. So, geometrically, if we see this figure here, one can easily see that if the point P lies outside the circle, then the distance between this point P and the center of the circle, so this distance has to be greater than the radius of the circle. On the other hand, if the point lies inside, then this distance between this point and the center is going to be less than the radius of the circle. And if the distance between this point and the center is exactly equal to the radius of the circle, then obviously it is, this point P is on the circumference of the circle. So, this is how we can find out. So, essentially what then we have to do is find this distance OP. So, OP is equal to square root of minus g minus a whole square plus minus f minus b whole square, which equals so now we say that if OP is less than R, then it follows that P lies inside the circle C. If OP is greater than R, then it follows that P lies outside the circle, and if OP is equal to R, then P lies on the circle. Now, using the expression of OP from the previous slide, so this is OP and we are checking to find if it is less than the radius r of the circle, which is g square plus f square minus c. So, if we simplify this condition by squaring both the sides, then what we will get at the end is that this condition is equivalent to a square plus b square plus 2ag plus 2fb plus c is negative. And note that this left hand side is nothing but this quadratic form with x and y replaced by a and b respectively. So, we just have to put the coordinates of this point P into this quadratic form and then check if what we get is less than 0 or greater than 0 or equal to 0. If it is less than 0, then the point P lies inside the circle. If equal to 0, then it is on the circle, and if this is greater than 0, then it is outside the circle. For example, suppose if we are given this circle C, which is whose equation is x square plus y square plus 6x minus 8y plus 4 equals 0. So, this circle, so 2g is 6, so g is 3, so the center is the x coordinate is of the center, the x coordinate of the center is minus 3. Similarly, the y coordinate of the center will be 4 because f is minus 4 and the y coordinate is minus f, which is equal to 4, and the radius will be square root of g square plus f square. So, that is going to be 25 minus c, which is 4. So, the radius is square root of 21. And suppose now we are given a point 2 comma minus 1 and we are asked to find if this point lies inside the circle or outside the circle or on the circle. So, we basically have to find this distance OP, which will be equal to square root of minus 3 minus 2, which is minus 5 whole square, plus 4 minus minus 1, which is 5 whole square, so this is square root of 50, which is greater than the radius, and therefore, it is now clear that this point P lies outside this circle. Next, suppose that we are given a line and a circle. So, suppose we are given this circle having this equation and we are given a straight line L whose equation is y is equal to mx plus d. So, now the very first question that comes to mind is if we see geometrically, then suppose if we have a circle, so this is a circle here, and then a straight line could either be like this. So, this is one case where the line does not intersect any point on the circle. Another case could be where the straight line cuts through the circle. So, it intersects the circle at exactly 2 points. And the third case could be where the straight line is actually a tangent to the circle. So, this is the third case. So, in this case the straight line only touches exactly 1 point on the circle. So, how do we know if we are only given these two equations? How do we find this out, whether which of these cases is true? Of course, one easy way is that we plot the circle and the straight line, but that might be time consuming, and of course, it is prone to errors. The other way is to actually try to solve this system of equations. So, since we are given that y is equal to mx plus d, let us use this fact in the first equation, because suppose that, let us say that the circle and the straight line intersect at some point. So, let the circle C and the straight line L intersect at some point P whose coordinates are A and B. So, what it means is that this point lies both on the circle and it also lies on the straight line, and therefore, the coordinates of this point must satisfy both the equations. So, what this implies is that since this point should lie on the circle, this equation should be satisfied with x equal to a and y equal to b. So, this equation should be satisfied. Now, since this point is also on this straight line, this equation should also be satisfied with x equal to a and y equal to b, and hence we also have this equation. And now, what we do is we substitute b equal to m a plus d into this first equation. So, in this first equation, wherever we have b, we replace it with m a plus d. We then get the following equation. And if we simplify it, we get, so we just have to open up this expression and this here. So, if we see this equation, it is a second degree equation in A, it is a quadratic equation, and therefore, there can be at most two real roots, which are two distinct real roots. So, if we get two distinct real roots for A, so if we get two distinct real roots in this equation, then what does that imply? That implies that there are two different real values of A. So, for example, we could have these values A naught and A 1, and then corresponding to A naught, since B is equal to M A plus D. So, when A is A naught, B will be equal to M A naught plus D. So, then we have this as one possible point of intersection. So, this could be one point of intersection. So, these two are the distinct roots of this equation here. The other point of intersection will be corresponding to A 1. So, when the x coordinate is A 1, the y coordinate will be M A 1 plus D. So, then when we have two distinct real roots, then we will have two different points where the straight line is going to intersect the circle. So, that will correspond to this green to this case where we have the green line cutting this circle at two different points, two distinct points. Another case could be where in this equation we have equal real roots. We have equal real roots. So, basically what it means is that we just have one root which is repeated. So, let the root of this equation for this case be denoted by A naught. And therefore, in this case where both the roots are equal to A naught, we will only have one point of intersection, and that point will be A naught comma M A naught plus D. And this case is basically the case where the straight line is such that it is tangent to the circle at some point. So, this is the case where we only have equal roots to this equation. And of course, the third possibility is that both roots are complex. So, there is no real root. Since we have no real root, it basically what it means is that there is no real value of A for which this thing is equal to 0. What that means is that the circle and the straight line never intersect. In this figure, this thing corresponds to the case of this red line. As you can see, the red line never intersects this circle. And further, it is very easy to also see the cases where just by looking at this coefficients, and in fact, just by looking at the discriminant of this quadratic equation, one can figure out which one of these three cases is applicable. Let us take a little example here to just to illustrate this particular idea. Let us consider the circle x square plus y square plus 2x minus 4y minus 4 equals 0. So, as you can see, the center of the circle is at minus 1 comma 2 and the radius is 3 units. Let these be the coordinate axis, and we have the origin here. So, the center is at minus 1 2. So, this is the center here. So, this point is minus 1 and 2. And the radius is 3 units. So, the circle is approximately something like this. And now, suppose if we are given a straight line x plus y equal to minus 5. So, this straight line is going to intersect the x axis at this point minus 5 0, and it is also going to pass through this point on the y axis. So, the straight line is something like this. So, in this case, obviously, we can geometrically, by drawing it, we can see that there is no point of intersection between the circle and the line. But how do we see that mathematically? Well, we can just proceed exactly as we did. Now, if there is a point having coordinates x and y which lies both on this circle and this line, then both these equations should be satisfied by the coordinates of that point x y. So, suppose we have a point x y. Now, from here we know that y is equal to, since this point also lies on the straight line x plus y equal to minus 5, the y coordinate should be equal to minus of x plus 5, where x is the x coordinate of this point. Using this fact in this equation here, because this point of intersection will also satisfy this equation of the circle. So, using y equal to this, using y equal to minus of x plus 5 over here, we get and if we simplify this, we get So, this is what we get, and the roots of this equation are (16 square is 256 minus 8 times 40, 8 times 41 is 328. So, as we can see, both the solutions are complex valued, because the discriminant is negative, and since both the roots are complex, it follows that there is no point of intersection, and that is what we exactly saw in this figure here. So, similarly, the student should also try to take some example of some other line which is actually passing through this circle. So, it is some line which touches both let us say 2 points on the circle, and then try to show it using the analysis which we covered. Try to get the second degree equation and then check that there are actually two distinct real solutions to that second degree equation. So, the next topic is how to find out the intercepts made by a circle on the coordinate axis. So, let us see what we mean by intercept. Suppose this is the x axis, this is the y axis, we have the origin here. And suppose that we have a circle whose center is at 1, 1 and has a radius of 3 units. So, the circle is something like this. So, as we can see, this circle is cutting or intersecting with the x axis at these 2 points, and it is intersecting with the y axis at these 2 points. So, this distance or this length here, so this length between the 2 points where the circle intersects with the x axis. So, this length is called the intercept made by the circle on the x axis. So, this is the x intercept or the intercept made by this circle on the x axis. So, that is this length. And similarly, the length of this part of the y axis between the 2 points where the circle intersects with the y axis. So, the distance between those 2 points is basically the intercept made by the circle on the y axis, or in short y intercept. Now, the question is, if we are given the equation of a circle, how do we find out the value of these intercepts? So, next we will discuss a method where if we are given the equation of the circle, then we should be able to find out expression of the intercept made by this circle on the x and y axis. So, suppose this is your x, this is our x axis, and so this is the x axis, this is the y axis. We have the origin over here, and suppose if so suppose this is a circle over here with, let us say, this being the center. So, to find the x intercept, we will have to first find the coordinates of these 2 points. Now, this point where the circle is intersecting the x axis will obviously have its y coordinate to be equal to 0. So, these 2 points are of the form a comma 0. So, we have a point of this type which is on the x axis, and this point is also on the circle, as we can see. So, it must, the coordinates of this point must satisfy the equation of the circle, that is a square plus 0 square is 0 plus 2ga plus c equals 0. As we can see, again this is a quadratic equation, and the 2 roots are given by minus g plus minus square root of g square minus c. So, one word of caution is that I have been using I would say an uppercase C to denote a circle, and this lowercase c is for the constant term on the left hand side of the circle's equation. So, this is the lowercase c. So, this is also the lowercase c. Now, we can clearly see from here that if g square is less than this c, so if g square is less than c, then there are no real roots of this equation. Then, since there are no real roots of this equation, it means that there is no point of the form a comma 0 which lies on this circle, and that what it essentially means is that the circle never intersects the x axis. So, if g square is less than c, then the circle does not intersect the x axis, in which case the intercept is there is no intercept essentially. So, this is the case of no intercept with x axis. The other case is if g square is equal to c. So, this particular case could so this figure does not correspond to this case, because in this figure we see that there are 2 points where because in this figure we see that the circle is intersecting the x axis at 2 points. Now, if g square is equal to c, then this is 0 and both the roots are equal to minus g. So, if g square is equal to c, then we have 2 equal roots, which implies that there is exactly one point where the circle intersects with the x axis. Or basically, there is exactly one point which lies both on the x axis as well as on the circle, and that point obviously then so therefore, if g square is equal to c, then the circle touches the x axis at the point. So, the value of a is minus g. So, the point will be minus g comma 0. And in this case, since both the roots are equal, the value of the intercept will be 0. So, if g square is equal to c, the intercept of this circle with the x axis is 0. And the third case is when g square is greater than c. So, if g square is greater than c, then we have 2 distinct roots. So, one of the roots, so we will have 2 distinct roots of this equation. So, the 2 roots will be minus g plus square root of g square minus c. The other root is minus g minus g square minus c. So, for this case where when g square is greater than c, the circle intersects the x axis at two distinct points, which are so this is one of the points, and the other point is this. And then the value of the intercept made by the circle on the x axis will be the distance between these 2 points. Intercept made by the circle on the x axis equal to, on the x axis will be equal to, so the distance between these 2 points will be 2 times square root of g square minus c. So, this is the expression for the intercept made by the circle on the x axis. And similarly, it is left as an exercise for you to show that if f square is greater than c, then the intercept made by the circle on the y axis is 2 times square root of f square minus c. If f square is equal to c, then the intercept made by the circle on the y axis is 0, and if f square is less than c, then so in this case the circle basically touches the y axis at a point, and the coordinates of that point will be 0 comma minus f. And in this third case, if f square is less than c, then the circle does not intersect with the y axis. Next, let us look at some problems. So, here is one problem where it is said that we have a circle whose equation is this: x square plus y square minus 2x minus 6y plus 6 equals 0. So, the center of this circle is at 1 comma 3. So, this circle is drawn here in green color, and the radius of this circle is 2 units. And then it is said that one of the diameters of this green circle, which is drawn in green. So, let us consider this diameter PQ, P to Q. So, this diameter is actually a chord to another circle which is drawn partially in red, and this red circle is centered at the point 2 comma 1. The question is asking us to find out this radius of this red circle. So, it is not very tough, because it is given that since this green line segment is a diameter of this green circle. So, let us say that the center of the green circle is O, which is here, and the coordinates is 1 are the coordinates of O are 1 and 3. And since this diameter of this green circle is a chord of the red circle, it is clear that we will have 2 points P and Q, which are the endpoints of the diameter, but then this P and Q will also lie on the red circle, because PQ is also a chord of this other red circle. Let the center of this red circle be this point A, whose coordinate is given to be 2, 1. This coordinate is given to be 2, 1, and we are asked to find this distance AP, which will be the radius of this red circle. So, now if we connect this point A to this point O, then we know that this angle POA is going to be 90 degrees. That is because if we connect A to Q, then we see that these two triangles POA and QOA are congruent, because this side and this side, so this side of POA is equal to this side of QOA, because both these lengths are radius of the red circle, and then between these two triangles this side is common. Further, because O is the center of the green circle, PO of triangle POA is equal to QO of triangle QA, because this is the center of the diameter. And since these two triangles are congruent, these two angles will be equal, and therefore, since POQ is a straight line, both these angles will be 90 degrees. Now, if we look at this right angle triangle POA, so if we zoom it and show it here, let us say this is A, which is 2, 1, this is O 1, 3, and this is P. So, we are asked to find this distance. Now, PO is the radius of the green circle, and from this equation we can see that the radius of the green circle is 2 units, and therefore, this distance OP is equal to 2 units. This distance OA can be easily calculated, because we have the coordinates for both O and A. And that is equal to square root of 5. And then it is very easy to see that if we apply the Pythagoras theorem to this triangle OAP, we will get this length to be 3 units, and therefore, the radius of the other circle shown in red is 3 units. So, with that we will finish this lecture. In the next lecture we will see some more problems, and we will also see how to derive the equation of the tangent and normal to a circle at a given point. Thank you.